I have this really nice opportunity to present what we have done in Ramtech to install this new test method for testing of cohesion and internal friction angle of cold recycled bitumen stabilized materials. When we're doing a recycling project, generally with us, what we focus on is what is in the roadway construction. And in a very beginning, we spend a lot of time and a lot of effort to find out what's wrong with the pavement, and we do a lot of tests, including all the tests on a roadway and also tests in the laboratory. But when we come to recycling, then we test really very few properties of recycled mix. And therefore we decided to put more effort into finding what can be done to understand to understand this material in a better way. So what we did, we set up a list of goals that we wanted to achieve to learn how to test the cohesion and internal friction angle of a cold recycled material. Within these goals, definitely one of the really major points is to find the relationship between composition of this material and the property. If we find this, which is actually nothing really new, but for new materials, for every material actually is a new material that you deal with. Then you can make a relationship between traffic loading, and that will bring you, or it will help you to find what actually cohesion do you need for this traffic loading that you're designing. Also, one of the goals is to characterize this cold recycled mix at the mix design stage to help you understand what is the property of material that you really deal with. And finally, cohesion and internal friction angle can be used in a pavement analysis when you use software-based methods for analytical finding out what are the dimensions of the pavement. We set up a research plan, and within this research plan, we actually had an idea to deal with materials that are crushed and combined with the reclaimed asphalt, and also the materials that are graveled materials that we have in eastern part of Croatia, in a Drava River area and in Sava River area. These two combinations of a crushed material and a gravel material combined with the foam bitumen, cement and lime, we came to roughly 600 specimens of different combinations. And these specimens are of, let's say, 12 kilograms, and this is actually a lot of material to work with. So this is just to give you an overview what was really required to complete those tests. This provedba programa means implementation of the program. What was necessary to implement this program of testing is, or program of research, was to choose the method, test method. And it will be, I will say more later in detail about this literature. Second, it was necessary to learn how to prepare specimens. This is one of the key points as well. Accelerated curing procedure, that's one of the issues that also required a lot of effort. And finally, then, when you have all that done, then a monotonic triaxial test procedure takes a couple of seconds, and then what you get, that's what you get. Also, we, at the end of this implementation, we prepared the laboratory test instructions, test sheets, and reporting, which is a part of every laboratory that is accredited. So, we have, doing this literature review, we have made a really fruitful cooperation with specialists from Stellenbosch University in Cape Town, and also from a company, Loudon International, from Durban, also from South Africa, both. These gentlemen, they have set up this research method. What I'm discussing here is a research method. It's not, it is not a standardized method. So we followed what's now latest findings in a couple of laboratories in the world dealing with these tests. This is we went through these procedures, and we adopted some of good things, and also we disregarded some of the bad ones that I will show you later. So just to get an overview, what tests are to be done, just briefly. There are many, but in the beginning, when you get your material from the site or from a stockpile that people don't know what to do with it, what you do is moisture content and gradation of the material. Then you do your combination of these ingredients. You find your moisture content according to modified Proctor, and also according to vibratory hammer procedure. It was very interesting to compare those two moisture contents and densities as well. It will be shown later as well. Sample compaction using vibratory hammer is a very tricky procedure, even though there were really other options as well. There is a possibility to use a vibratory table and maybe a gyratory compactor. In some cases was used, but this is also one of points for further discussion. Curing is a procedure that takes approximately 5 days, and during this procedure, you have to test or to follow what's the loss of a moisture content, and you must be able to actually bring a sample to 50 to 60% of moisture content at the end before testing in a triaxial testing machine. Just to get an idea of what was the material that we were testing, just to learn how to test, we took 35, 65%, 35% reclaimed asphalt, and 65% crushed material, and that material actually looks like a G4 material according to US specification. It's a 5% passing on 100 microns. It's approximately 40% passing on it looks like a good sub-base material for a mechanical sub-base. Now, what I wanted to show here is a optimum moisture content On the left one is the right one. It shows the modified Proctor curve, but on the right one, I have a wrong slide here. The right picture is supposed to be showing vibratory hammer procedure, which actually does not have this nice parabol. It goes up, and it doesn't stop. And the reason for that is because you have a sample that you compact in a split mold, and you lose fine mortar material that goes through this split mold, and it seems like you have to add more and more water, and it doesn't stop. So this procedure is actually finding optimum moisture content using vibratory hammer. That doesn't work. Even though some people try to explain that it does, but it didn't work with us. Preparing a sample of 150 by 300 millimeter is it was done with a vibratory compactor that is actually described in a European norm for a modified Proctor. What was done there, we did it in 5 layers, so it's approximately 6 centimeters a layer, and each layer was compacted with different compaction time. And we found that following these times, compaction times, and using this, the vibratory hammer did not give you a density of a material that you actually achieved on modified Proctor. So from this exercise, we found that you need higher compaction energy, and that means stronger machine. And the machine that is, therefore, the machine explained in a European norm doesn't work again. Actually, it's understandable because it is foreseen for a small, for a sample of 6 by 6 inches or 150 by 150, and it's not foreseen for 300 millimeter sample. Curing procedure is a tricky part. You produce a specimen. It's still it is compacted and it's kind of firm, but you can lose fine material on the edges, and you have to be very careful. It's 12 kilograms mass, so you have to be really careful to bring it to the oven and not to disturb the sample. Sample has to be covered in a plastic bag, so not to lose excessively or quickly lose moisture, but to lose moisture during this five days period constantly on some, let's say, linear pace. Finally, when you get to this point, you're really happy that you have your sample in one piece, and you look at you need at least 8 samples, or 12 better, and you split them in four groups, and each group is tested on a different sigma 3 lateral compression, lateral pressure. The testing machine is shown. I'm not going to go through details here because the machine is actually in front of this hotel in this very nice truck, and I'll be happy to discuss anything that you may have asked or would like to ask over there. So be happy to do that. Just one more slide on that. Now, I know that when you show a slide like this, you lose 50% of attention of people, but just to get an overview, what we do is we measure a compressive strength of a material and calculate this compressive strength, and then doing a linear regression combining with the sigma 3, you come to this cohesion and internal friction angle. This is also one of those slides, not to show very often. It shows the graphical illustration. It's more Coulomb, actually, showing more Coulomb law used on these calculations now. This slide shows the compression and stress and strain. Actually, stress is on a vertical axis, and a strain is on a horizontal. And so the blue line is one without sigma 3, not laterally pressed, and each consecutive one is pressed with 50 kilopascals, 100 and 200. And actually this, if you get this in your test results, then you can go into calculations. Otherwise, if those curves are similar, then your phi will be just a flat line, and that is actually not the material that you would like to have. Just to have an overview, just to have an insight, what are the trends? Everyone knows it's recycled material should be stabilized with 1.8 to 2.5% bitumen max. But this procedure that takes approximately 1 week help you minimize or optimize actually the bitumen content, and if you on a bigger project, if you save 0.1% bitumen, then it pays off quickly, this 1 week work. So as I said earlier, compaction time is together with a stronger vibratory compactor is something that is really necessary. Also, we are looking into doing tests on gyratory because it doesn't take that much physical work. Curing is something that is really to be worked on. This procedure that was described in this appendix cell, what I showed previously, is something that really needs attention, depending on the material that you're working with. I would like just to thank you again, and to say that if you have any questions, we can discuss it here, of course, but all the details you will be able to see in a container. Thank you very much.